we're just going to kind of do an overview of some of the big things in stats. These are some of the big terms that you will hear me use. If you look, and I know it's kind of annoying, it's going to bounce back and forth between these two handouts, but when you look back in your notes, this will be a more convenient way to look back at it. So if you start on your terminology page, statistics in general, you're taking a statistics class. So what in the world does that mean? And statistics is collecting, organizing, summarizing, and analyzing data to draw some kind of conclusion or answer a question. So collect it, and then what do you do with it once you get it? And then how do we organize it so it is meaningful, and what does it actually tell us? So this is what you want to write down on that statistics. Our whole goal is just to understand some kind of variable, understand why things vary how they do. I'm going to jump down for a second, and we're going to this table here. So this is probably one of the most important ideas that we are going to talk about in statistics. We're always going to talk about a sample versus a whole population. And the difference is very, very important. The population is the whole group. Okay, if I want to see if yesterday's assembly helped you guys get more excited about the school year, my population is the entire high school. Every student in that high school. So the population is everyone. So there's kind of a picture there to remind you. You can write this definition just in that same box with the picture, just right underneath your picture. It's the entire group. Now, in real life, it's always best to ask the whole population. Why would I maybe not ask every single student in the high school if yesterday's assembly made them more excited? What would be the downfall of that? It takes a long time. That is the #1 reason. It is often just not feasible to talk to everyone. So I might take a smaller group. What if I just asked you guys? You're all part of the population, but you're not the whole thing. You're just a few people out of that. That's a sample. It's a subset of the population. It's part of them. If I took the whole group and I pulled a few out, that makes up a sample. And then an individual, that's what we already mentioned on that one handout we were looking at. It's just a single person. So the population is the whole. If I take a group out of that, that's a sample. And if I just ask Eli, he is an individual. Okay. Now, if I just ask you guys, and I get that 86% of you said yes, yesterday's assembly made me more excited about school. Does that mean that 86% of the entire student population was more excited? Not necessarily. Why would you guys maybe be different? Because you are different. You're in an upper level math class. Does that make you different than some of the others? Sure. How many Stuco members do we have in here? Does that, yeah, so Stuco members, are you different because you planned the assembly, you had a part in that? Could your opinion be different than a freshman who that was their first experience in high school? Absolutely. So samples are good, but we have to have a good sample. And we will talk a lot about that in the coming weeks. What is a good sample? How do I know if the data I'm getting is good? So when I'm looking at the numbers I get, it's important to know when I say 86% of students thought that the assembly made them more excited for school. It's important to know, is that 80% or 86% of everybody or just the people I talk to? Okay, that there is a difference there. Okay. So, going back up, under statistics, the whole realm of statistics really falls into two different groups, descriptive and inferential. Okay, and you can paraphrase here if you want. Descriptive is organizing and summarizing data. I'm taking my data and I'm just showing you what I found. I'm showing you that dot graph we made from the Pepsi experiment. That's descriptive. I'm just describing what I found. Inferential is when we take the results and extend it to the population. So inferential, I'm trying to draw some conclusion from what I found. So if I said in my Pepsi experiment in our class, there was a 3.6% chance of having 2 or less winners. Is that descriptive or inferential? Did I tell you what happened, or did I try to make some conclusion from that? Descriptive. I just told you what happened. Okay, I didn't extend that to anything else. I just gave you the facts. If I said, well, there was a 3.6% chance that that happened, so Pepsi must be lying to us about the 1 in 6 chance of winning. That's inferential because I took what I found and I tried to make some assumption from that. Okay, the whole goal of statistics is really inferential, where we have to do our data and then try to make some guess. You know, before a presidential election, there's all kinds of polls and you're seeing who's in the lead, and why would they do that? To try to guess at who's going to win, right? So they're trying to make some inferences, but that's not 100%. That's just our best guess. Okay. Am I going too fast? Have I lost anybody? Thrown too many terms at you yet? So when I'm taking the different numbers, there is a difference between statistics and parameter. And this goes back into the population and sample. So I kind of line them up. And you can remember this because population and parameter, those both start with P. Statistic and sample both start with S. So a parameter is a number based on the entire population. I'm sorry, these are in a different order than on your notes. Make sure you write it down correctly. A statistic is from the sample. So if I said, you know, in the Pepsi activity, 1 in 6 wins. 1 in 6, that's out of all the Pepsi bottles. All the Pepsi bottles is the entire population, right? So that 1 in 6 would be a parameter because it was the entire group. In our activity, would you guys be a population or a sample? A sample. So if I said the 3.6%, that would be a statistic because it's a number I got from my sample. So if the number comes from the whole group, it's a population, so the number is a parameter. If it comes from my smaller group, that group is a sample, so my number is a statistic. So that table right there in the center is probably the single most important thing that I'm talking about today. Let's flip over. We're tired of writing definitions for a minute. Let's flip over to our example. All right, so one-word answers. That's why I printed these, because I didn't want you to have to write, you know, a paragraph just to give me a one-word answer. I just want to know, is this descriptive or inferential? Those are my two choices. So the first one, the average age of 500 surveyed students in your institution is 23 years. Descriptive. Did I make any guesses? No, I just told you what happened. I described something. You can abbreviate if you want. Okay, B. Based on a sample of 10,000 Americans, it is fair to say that 70% of all Americans are overweight. Inferential. I didn't say 70% of my group. I took those 10,000 and I tried to extend it to everybody. So I made some guess about what that meant. So that's inferential. Right, C. 80% of students in your statistics class dislike true-false questions. Descriptive. I'm just telling you in your class what happened. Based on a sample of 20,000 college students, we may conclude that 80% of all college students dislike true-false questions. Inferential. We understand the difference between those two? Let's look at parameter versus statistic. Okay, so when I'm talking about a parameter, that deals with what? The entire population. And a statistic deals with a sample. Suppose the percentage of all students on your campus who have a job is 84.9%. All students. So all students, that's talking about my population, my entire group. So this 84.9 would be a parameter. The parameter or statistic, I'm referring to that number in there. Okay, suppose a sample of 250 students is obtained. So I have that word sample. And from this sample, we found that 86.4 have a job. So 86.4% here would be a statistic. I want you to try the next one on your own. I want you to read this and write down 3 things. I want to know what your population is, what your sample is, and what an individual would be. CBS conducted a poll in 2013 and asked, do you favor or oppose raising minimum wage to $10.10? They surveyed 1,009 adults and found 706 were in favor of the increase of minimum wage. CBS reported that 70% of Americans were in favor of the increase with 3% error and 95% level of confidence. Okay, there are a ton of numbers in here, but most of them aren't really relevant to what the question I'm asking you. Okay, sometimes it's not specifically stated. The population here, I didn't really say what the whole group would be. But what do you think? Adult Americans, right? That's who they're concerned with. The people that are out there earning the money. They talk to adults, and we would assume we're talking about Americans here. They probably don't care about the opinion of a 5-year-old in this case, or of somebody in another country. Now you could make the argument that they should probably be concerned with teenagers, because you guys have jobs, right? But didn't say anything about surveying those people. So what would my sample be? My whole group is every adult American, which we know it would not be feasible to talk to every single person. So who did they talk to? 1,009 adults. Okay. What would an individual be? Yeah. So each adult or one adult, just one person that they talk to would be an individual. So sometimes it's not specifically stated and sometimes it is. We just have to kind of read into the question a bit to understand. All right. I have a few minutes left. So what I want to do write down the last few definitions and then we will talk about them tomorrow. Sound fair? Okay. So back to our definition. We actually kind of hit on all of these on that handout with our Pepsi activity: variables, qualitative and quantitative. So a variable is just some characteristic. It can be anything. It can be a number, it can be an attribute. It's just something that we're interested in. The two types, qualitative, sometimes that's called categorical, means the same thing. That's the one that's based on an attribute or a characteristic. Quantitative, like we said before, is numerical. Quantitative. Here's what I mean by that. On Friday, football players are going to come wearing a jersey, right? And what's on the back of every jersey? A number. Does that number have a numerical meaning? No. Can I add two of those numbers together and make meaning of that? No. What is the purpose of that number? To identify the person. So all the number is a way of separating the person. So is that really quantitative? No, because it doesn't have a numerical meaning. So if I alphabetized you, and the first person was number 1, the second person was number 2, would that have a numerical meaning? No. So we do have to be a little bit careful. You can't just, every time you see a number, say automatically quantitative. Most of the time it is. But there are certain things like that that are not. We will talk more about this tomorrow. So your homework tonight. If you did not get your syllabus signed, do that and bring it to me. If you have not gotten into Classroom and done that introduction survey, do that. If you have both of those done, then you have no homework.
I got it signed.